Hello students. So today we are going to discuss this very interesting problem from HCVerma from the chapter Laws of Motion. It says let m1, m2 and m3 be three masses. The value of the masses is given to you. And they ask you to find out the acceleration of the masses for the given figure. Also they have told you that there is this mass m1 which is at a distance of 20 centimeters from the pulley p1 when it is released from rest. And how long will it take before m1 strikes the pulley? This time also we have to find out. So let us go ahead and see how we work upon this problem. So I have drawn this figure for you all. Please look at a few things before we start solving it. So here we have this pulley p1, the pulley p2, and the masses m1, m2 and m3 as you can see. So assuming that initially we have to take some directions where we can start the motion, considering the motion of the particles from. So we are assuming here that let's say m1 moves up with an acceleration a. So here we have shown that acceleration. You all should understand here that if m1 moves with an acceleration a upward, the pulley p2, which is directly connected with m1 through this string that goes over the pulley, this string, since the two are connected through a single string, with whatever distance m1 goes up, the pulley p2 will go down by the same distance, and this also means that with whatever acceleration m1 moves up, p2, the pulley p2 will move with the same acceleration downward. So this is one thing that I have shown here, this acceleration a upward for m1 and the acceleration a downward for p2. Next is, if we assume that p2 the pulley is at rest, then the same thing, the same relation between the acceleration can be applied across the blocks m2 and m3, which are connected through one single string that goes over the pulley p2 also. So we assume here that if p2 is at rest, if we consider p2 at rest, which means if we try and work in the frame of p2, then the block m2 will go up. If it goes up with an acceleration a dash, m3 will come down with the same acceleration a dash. So using these facts, we are going to start our solution. So here we assume that let the acceleration of the mass m1 be a upward. Then we know that the acceleration of p2 the pulley will be a downward. Yes. Next, if p2 is considered at rest, that means if we work in the frame of p2, in that case what will happen? If we assume that the acceleration of m2 is a dash upward, then the acceleration of m3 should be a dash downward. Mind you, these two accelerations that we have written here, a dash upward and a dash downward, are in the frame of p2 when p2 is considered at rest. So they are not the accelerations with respect to the ground, they are actually with respect to the pulley p2. Now what we are going to do is we are going to use relative motion to find out the accelerations of m1 and m2 and m3 in the ground frame. So what we do is, using the relation for relative acceleration, acceleration of m2 with respect to the pulley p2 will be by definition the acceleration of m2 minus the acceleration of p2, isn't it? So we use this to write this expression here. Acceleration of m2 will be acceleration of m2 with respect to p2 plus the acceleration of p2, and here we will substitute these values. So we know that the acceleration of m2 with respect to p2, that means when p2 is considered at rest, we have assumed this acceleration to be a dash in the upward direction. So we write here a dash. Similarly, the acceleration of p2, which we have taken up to be a downward, this will be, because we are adding up two vectors here, we have to be careful with the signs. So if we have taken a dash in the upward direction, this a, the acceleration of pulley p2, since it is in the downward direction, we have to take it with a minus sign. So here you need to be a little careful while putting the signs. Now the next thing, similarly we can find out the acceleration of m3 by writing a similar equation. Acceleration of m3 will be acceleration of m3 with respect to p2 plus the acceleration of p2 and substituting the values along with the sign. So acceleration of m3
With respect to the pulley P2 came out to be A dash downward. So, we have taken A dash with a positive sign, that means here we are taking downward direction positive, plus A, the acceleration of P2, which we know is A downward. So, both of them will have same sign here. So, understand that we are able to find out the acceleration of M2 as well as M3 in terms of their relative acceleration with respect to the pulley and the acceleration of the pulley. Now, these are the actual accelerations as seen from the ground. Now, what we do is, we come to the use of free body diagram of the 3 blocks and using the Newton's second law on them. So, this is the free body diagram here. As you can see from the above figure, we can relate the tensions in the 2 strings as well. Assuming that the tension in the lower string, the one that connects M2 and M3 is T, we can say that the tension in this upper string will be 2T. How do we get that? We know that this pulley P2 is massless. There is no mass given here in the question for the pulley P2. So, we can assume that it is a massless pulley, and for a massless pulley the net force acting on it will always be 0. So, if we have a tension T in the lower string, this T will act on the pulley here as well as here, creating a net tension of 2T in the pulley in the downward direction, and to balance that 2T there should be an upward 2T acting on the pulley, which will come from the second string. So, here we get a relation between the tension in the first string and the second string, and this is how we show it. Now, once we know the tensions, relation between the tensions, we can draw this free body diagram. See carefully that we have drawn free body diagram each for M1, M2 and M3, and we have shown their direction of accelerations also along with their magnitudes as we have obtained in terms of A and A dash. Now, we are going to write the Newton's second law for all the 3 blocks. So, for the first block, since the acceleration is upward, we will write net upward force is equal to mass into acceleration for the block M1, which will give us 2T minus M1G is equal to M1A. For the second block, again the acceleration is in the upward direction. So, we will have net upward force, which this time will be T minus M2G, and it comes out to be M2 into A dash minus A, which is the acceleration in the upward direction. For the third block, we have the net acceleration in the downward direction. So, we will write the net downward force is equal to mass into acceleration, which gives us M3G minus T, that is the net downward force, is equal to M3 into the acceleration of the block M3. So, we have got 3 equations, and if you look at it carefully, we have 3 unknown variables here. One is T, the tension in the string, the second one is A dash, and the third one is A. 3 variables, 3 equations. Understand that we can solve for all the 3 using these 3 equations. So, we will do that one by one. Solving these 3 equations, first of all you can use equation 1 and equation 2, connect them together so that you can get a value for T here in terms of A plus G, and use that value of T over here in this equation, and that gives you this equation that I have written here below, the equation number 5. Similarly, you can use equation 2 and 3. These 2, connect them together. How? If you look at it, you have a plus T over here on the left hand side and a minus T here on the left hand side. So, if we just add the 2 equations 2 and 3, add them, we will have T cancelling out, and we will be able to get a relation between A and A dash. So, this is the equation that we will get after solving equations 2 and 3. So, we have got 2 equations both in A and A dash in terms of G. So, we can solve both of them to get the final values of A and A dash. These are the 2 values that we shall obtain after solving these 2 equations. Once we get A and A dash, now the final job would be to find out the actual velocities of accelerations of M1, M2 and M3, which we have already shown here. For M1 it is A itself, for M2 it is A dash minus A, and for M3 it is A dash plus A. So, we are supposed to find out these 3 values now. So, we substitute the values, we get acceleration of M1, which is A itself, which will be 19 G by 29 upward, because we have taken the acceleration of M1 to be in the upward direction. Acceleration of M2, which we saw it to be as A dash minus A, when we substitute the value of A dash and A, we see that we are getting a negative value here. Now, what does the negative sign here mean? is that the direction of the acceleration of m2 is opposite to the direction that we have considered. So, if we just go back and look at it, we have taken the acceleration of m2 to be in the upward direction. So, this minus sign is telling us that this acceleration is actually in the downward direction. So, we can remove the minus sign here now and write downward instead of upward. Next is the acceleration of m3, this has to be m3, I am sorry. So, acceleration of m3 will be a dash plus a, and when we substitute the values for a dash and a, we get the value of acceleration of the mass m3 as well. So, once we obtain all these three accelerations, our answer to part 1 is finished. Now, in order to move on to the part 2, the part 2 asks you to find out the time that m1 would take to travel a distance of 20 centimeters up to the pulley, because its distance from the pulley is 20 centimeters. So, I have just drawn a partial figure here, just showing the distance that m1 is supposed to travel. So, see that once we know the acceleration with which m1 is traveled, it is quite simple to calculate the time that it takes to travel a certain distance. We can directly use the second equation of motion s is equal to ut plus half at squared to get it. So, when we just substitute all the values and solve it, we will get the value of t simply here as approximately equal to 0.25 seconds. So, see here guys that we have used the concept of relative motion, specifically relative acceleration here to solve this problem, which could otherwise look a little tedious, look a little complicated to solve. Relative acceleration, the concept of that makes this question quite easy to solve. We just have to get two variables. In terms of two variables a and a dash, we are able to represent the acceleration of 3 blocks here, yes, and then we are able to solve for all the 3. Thank you.